All right. Good morning. I thought I had to do something to make sure you are awake when the session starts. Thank you guys for waking up early, joining this session on maximizing Windows performance. It's basically two pillars in this session, or it's based out of two pillars. The first one is explaining what Microsoft has done in terms of performance changes all the way back since Windows Vista up to Windows 8. And then what we can do when we have an application, when we have a driver, or we even have Windows not behaving the way it's supposed to be. It may come as a complete shock to you, but sometimes that happens. All right. As all the MMS sessions, this one has a hashtag on Twitter as well. So if you want to post questions or comments or whatever, make sure to direct them to that hashtag, DCB313, and also please tag them with MMS and my Twitter alias as well. I monitor them here on this laptop, so if I get a chance, I can be able to answer questions during the sessions. But if I don't have time to answer them all, I will make sure to follow up and answer them later on today. That being said, my name is Johan. I will be your host now for some 73.5 minutes. And I've been an IT guy since I was about 10. I started to work as an IT pro when I was 16 years old. And I'm turning 40 this year, so it's been a while now. It was easier back then. Deploying DOS, copying a floppy, done. Now it's more complex. Now, I brought the lab environment. This is a laptop, 32 gigs of RAM, 1.2 terabyte of solid-state drives, 8 cores. It's a pretty good demo machine. If there is one single thing that you take away from this session, I would like it to be that when you come home, you ask your manager for a machine like that. Please say hello from me. I have no problem with that. But this allows me to test and try stuff in high-speed environments. In fact, this laptop will outperform most customer servers these days because of the massive I/Os you get from SSD drives. And in terms of Windows 8, if you back 4 or 5 years ago, you normally bought more memory to get the machine more performant. No, not anymore. You get a solid-state drive. And suddenly you have a laptop or a desktop that could run in circles around a machine that doesn't have a spindle disk. Last MMS here, it was not here in Mandalay, it was in Venetian last year, I met one of the brightest, smartest customer I ever met in my life. It was a 3,500 company, so not that big, but not small either. They have just made a decision to replace every single hard drive in all their desktops, all their laptops, to solid-state drives. Because they have realized that the extra speed they got actually paid for those drives in just a few months among their 3,500 people. I thought that was pretty cool. But I will have a domain controller, I have a Windows 8 client, and have a Server 2012 host, and I will be using one of the others as a file server when we do some of the other tests here. Now, performance was, of course, critical. I'm pretty sure that all of you have been, at some point in time, frustrated that you do something and it doesn't immediately respond. Or you start an application and it appears to hang, and it simply takes a long time for it to start. Or you try to log on to a machine or boot the machine, and suddenly it takes 2 minutes to boot it, and you scratch your head and try to figure out why. This is what we'll try to find out the reasons for in this session. At least I will show you the tools and methods to do it. Now, when we define performance, it's really about having a system that is responsive. because an unresponsive system, no matter the user, will give a look like this on that user. Now, in a machine, there are quite many components that are fighting together. And it only takes one bad component to actually break it for others. So in terms of applications and drivers, etc., it's only one driver that could be faulty that could affect performance of the entire machine. If one driver takes 2 minutes to boot or 90 seconds to load, it will impact the entire boot of that machine. Luckily, in Windows Vista and beyond, we have tools. We have measurement tools in Windows that can help us troubleshoot this, which did not exist back in the XP days. Now, believe it or not, but Microsoft's performance work actually started back with Windows Vista. The word Vista and performance is not something you normally would put in the same sentence without a not in between or something, but this is where the work started. This is where the vendors started to learn to write drivers for the new driver model that is still based now in Windows 7 and Windows 8. And it took them a good few years to do that. It was not only the driver vendor's fault, because there were issues in Windows as well back in the Vista timeframe, which Microsoft solved in Windows 7, removed all the deadlocks and global locks they had in Windows, fine-tuned into Windows 8. But it was also because of the vendors learned how to create good or better drivers. You can actually, if you take a Vista RTM with the drivers from Service Pack 2, Vista, it will be a much better performant machine. But it wasn't until Windows 7 until this actually kicked in. So in Windows 7 and Windows 8, Microsoft continued to improve what they already had. The first two features are still in use, but they are being used differently. If you have a solid-state drive, Superfetch will behave differently than if you have a spindle drive. Superfetch is the mechanism in which Windows preload stuff that you normally use or start with the machine. ReadyBoost, I don't get it. ReadyBoost is the idea, if you have too little memory in a machine, you attach a USB stick or USB hard drive, and you use that as memory. No! More memory! If you don't have enough memory to run Windows 7, you should not run Windows 7. Don't try to compensate with an external hard drive. Boo! Don't like that. Then we have device drivers. In Windows 7 and Windows 8, the vendor's drivers are loaded in parallel when you boot the machine. Especially in Windows 8, with the new drivers that exist now and the new hardware that comes out with UEFI and all that, you can have a cold boot within 8 seconds. And this would not be possible unless the drivers were actually loaded in parallel and compared with one by one. I talked about the memory management, the uplocks that was removed. You will see that in Windows 8, logon time, when you have redirected folders, when you have roaming profiles, is much more performant than previous versions of Windows. But you can still experience logon times, and I will show you how to troubleshoot that later on. Then in Windows 7, Microsoft started to make more and more services trigger-based, meaning not running it all the time. And that continued in Windows 8. If you go into services, and I will show you this shortly, you will actually see that a bunch of them are based on triggers and started at certain intervals in time. So why does Microsoft do that? Why don't they have them just running? Well, to save battery life. When I first saw Windows 8, when the new start screen and all that, I thought that, all right. I figured people would either absolutely hate it or they would absolutely love it. I landed somewhere in between. I have accepted it because I liked all the other stuff that I get with Windows 8. I get the half-time or 45 minutes longer battery life I get on the same laptop I used to run Windows 7 on. I'm a gamer. I play StarCraft. I love the extra frame rate I get because I run it on a Windows 8 box. I get like the performance and the other 800 features they added. So to get that, all right, I'll live with it. Fine. Won't argue that point. And have your touch device, if I have a slate device, I won't argue at all. Perfect use for a start screen. All right. So let's swap over to the demo environment. And let us find a Windows 8 computer. Here we go. If I open up a defrag UI on the server, and I will also kick up Zoom it. Windows 8 and Windows Server 2012 will detect that the system has a solid-state drive. And it will change the defrag to something else. It will change it to a trim command, because you don't defrag a solid-state drive. If I would see that on a Windows 8 box, that is not a VM, because if I do that in a VM, I will only see the provision disk. If I can type the defrag UI, it says thin provision drive. But if I go to a Windows 8 hardware, it will look like this. Where you can see it's replacing, for the solid-state drive, it's replacing the defrag with the trim instead. So if you run a defrag on Windows 8, it will actually look like this. Let me see if I can pause it in the right spot here. Here we go. It's quite quick, but you can see it's running the trim command instead of running a defrag. So you do not need to disable any defrag services in Windows 8. In fact, you should not. You should simply leave it as is, because Windows 8 will detect the solid-state drive and adjust the system accordingly. The only time you need to do something on a Windows 8 box for having it to use and learn about the solid-state drive is you have a spindle drive and you have just backed up and restored Windows 8 to a solid-state drive and put it back in the machine or replaced it. Then Windows might not detect it. So what do you do then? Quite simple. Find a command prompt, run WinSat formal, and Windows 8 will now detect the solid-state drive and adjust all the services and components for a solid-state drive. But if it was installed with a solid-state disk, you don't have to worry at all. But this is something you can do afterwards. Also on my host, I'm using something that is not available for Windows 8, at least not supported in Windows 8. I'm using data deduplication. It's a file service that you can add. So if I go to my file storage, I have all my volumes. And on my data volumes, I have actually enabled deduplication. And I have a deduplication rate of 75 to 71%. Which means if I go to properties on a disk, and I did that this morning, this is the size of my VMs. I have about 100 virtual machines on this laptop. This is where the consuming disk. Pretty powerful. Now, if you do enable that feature on the server, please go into Scheduler, find the duplication schedules, and disable them. Because this feature in Windows does the following to your files. It will chunk them or chop them into small pieces and remove all the identical pieces. That's why I can have much more content than I actually use on disk. This was a feature that has been available for a few years in high-end SANs. Now we can have it on our Windows box in our demo environments. But the shopping mechanism is really effective. And if you have running virtual machines with the emphasis on running, it will start shopping the running VMs. And guess what? They crashed. And I have first-hand experience from that twice. For the first time, I thought it was a beta issue or something. No, it wasn't. So go in, and if you enable that feature, go in and actually disable the services, and life is good. And every time you need more space on the drive, you simply kick off and run the client commands. So I do that like every third week or so when I start to run out of disk space. Or you can do the equivalent PowerShell job to do the same thing. Works. Now, in Windows 8, I talked about the scheduled services. So if I open up services, you will see that quite many of them has a trigger start connected to them. So let me kick off Zoom it here and drill down into group policy, for example. In Windows 7, this one is always running. But in Windows 8, you will actually see it's not running all the time. It starts and stops any once in a while. So if I open up the task scheduler from a normal command prompt, you can actually see that Windows has some, let me see how many it has, 163 tasks currently being scheduled. 22 are running at this moment. But they are divided into all the products that we have. So for example, there will be a group policy schedule, which normally will show you exactly nothing. Why? Well, it's running, so it's apparently triggered, so there are no policies right now. Or is it? I'm not an admin. I need to elevate myself to see this. So I will open up an elevated command prompt. Control-Shift-Enter will give you elevation of everything you type in the start screen. Same as in Windows 7, but works in Windows 8 as well. So I will open up this one as well. So I'm now an admin, because I have a green background. Still nothing here. Most services runs as system, not as admin. So I need to be system. All right, let's be system. Now I'm system because I'm yellow. Now I will see everything that the system sees. And if there are any trigger services for group policies, they will actually be listed here. So this is where I will see the next time the group policy will kick in. I don't know if you have seen this, but in Server 2012, if you go to the domain controller, and I happen to have one here, if I can type the right password, it will help. If I open up the group policy console, I can select an OU, and I can select to do a group policy update. That will, Zoomit is your friend. Zoomit is the thing that allows me to not do this. This is the new task manager. If you have a process that doesn't want to do what you want it to do, you can kill it from here. You can start it again. And then you can zoom. Now you can select the group policy update on the OU. What it will happen is it will now go and run group policy update on all those 23 computers. But what it really does, it creates a schedule, a remote scheduled task on that machine to trigger the group policy. All right. And Microsoft has done that, as you saw, for quite much or many services that you have. And the reason is, of course, to save battery time on the machines. That's why Windows 8 has a much, much better lifetime in battery in terms of Windows 7. You will also see that products that are released with... How many of you are using Config Manager in here? A good few of you. Half of you. Sorry, there is no Config Manager in this session. But the Config Manager client is a very good example of a software that will behave differently depending on battery level on the machine. If your machine only has 20% battery, it will not do hardware or software inventory anymore. It's reducing itself. It tries to be a good citizen. The Config Manager team does not want to be the reason your laptop dies as you're about to check in on an airport, or your Slate device dies when you try to do the same thing. Okay. If you have a slow system, user normally will let you know. It can either be like this. It can also be a friend that calls on a Friday late afternoon. Or if it's a manager, it could be like this, asking the same type of help. But inside Windows, we still have a good few tools that can help us troubleshoot performance issues. They have been around for quite a while, but they have been changing a little bit in Windows 8. So if I go back here, and again open up the Task Manager, as you have seen, it's quite different from Windows 7. But you do have a Performance tab, which will give you the old view that you had. But you also have an application history of the most frequent used applications. Then, of course, you have the same detail on your services. So like Windows 7, you can right-click a process. You can set affinity, where you can divide it to a specific CPU. I only have one in this VM. But if I would do the same thing on my host, same process, I can tell which CPU to run it. It can be useful if you have really old applications that refuses to behave when you have multiple CPUs. Critical applications like StarCraft 1 that you want to run still. Now, you also have the weight chain, where you can right-click and you can say Analyze Weight Chain. And then you will see a sort of a Process Explorer type of view where you see what processes this one actually spawned underneath it. And that can also be useful to learn what an application is doing in my system. Of course, we have the good old perfmon. It's been around for quite a while. If I start perfmon, it will give me the performance view. And I can go and do open the resource monitor from here, or I can start to use the not-so-documented command line switches to perfmon. So I can do /report, for example, to kick off an investigation about my machine that will run for 60 seconds and collect information about this computer. Now, this is just a snapshot of the machine right now, but it still gives you information about what's going on that laptop, or this virtual machine in this case. You can also go into the control panel. So I will open up computer, and I will come back to this one later on. If I go System Properties, I have Performance Information and Tools. This is the indexing on Windows 8 machine. But if I go back, I actually have Advanced System Settings up here that I can click. And if I do, no, that's the wrong one. Advanced Tools, I will get the view of shortcuts to quite many performance-related functions in Windows. For example, if I go to Device Manager, and I go to a device, and I go Properties, I have an Event tab now on my Windows devices. And I can also kick in and open the event log that now tracks, and also in Windows 7 actually, it tracks information about all my devices. So in here, you will have information if a device driver, for example, takes longer time to load than it's supposed to. And you can quickly see that, all right, I can see that this device takes 4 seconds to load. It's supposed to take 4 milliseconds. And I can try to update the driver, and I have the history back to see if it actually helped. Okay. So back to my monitor. It's supposed to be complete now. I get the report back, and I can go to the headline view or the overview, and I can drill down into all the different areas that are related for performance that Windows has gathered about this machine. So for example, I can go to disk, I can go to hot files, and see what files are causing the most disk I/Os on my machine. It could be an application that is hammering an index, making my machine slow. But this is the type of information I can use to find out what application is actually hammering my hard drive. Not so interested in a solid-state drive, maybe, but if you have a spindle disk, absolutely. I can also open up Performance Monitor standalone. So I can do perfmon-sys, and it will give me just the old performance window that has been around since NT 3.something, 5 at least. And I can add to see, for example, the processor from my processor time from my local machine. But I can also use another switch called comp, which will open up a second window. And in that second window, I could, for example, add another machine. So I can add counters from my domain controller. Can you please pick them up? What could possibly go wrong in a live demo? All right. Try this again. Start comp again. Add DC01 again. That was funny. Here we go. And then you can do compare. You can say snap to compare. Still using the wrong machine. Interesting. I'm pretty sure I added DC01 here. I give it one more go, and then I'll give up on this one. I actually seen it happen one time before, so it's not a total new experience. Perfmon, select, let me try this again. Hey, my man. Thanks. What I was trying to demonstrate, I now have processes running on different machines at the same time. And now I can snap to compare and put the windows on top. And I can adjust the transparency. So I can now see multiple machines at the same time, and I can compare them to see if something sticks out, which is useful. And of course, you need to click the processor line twice. Right. Feature request. You also have the resource monitor. I showed you the link to it before. So you can either start it from here, or you can start Cypress Mon, and it will give you a quick overview from the system, CPU, memory, disk, and what processes are being active, the network, the same stuff. You can see what components that are doing what on the network. They can also be useful for troubleshoot efficiency. Then we have something extremely useful, and that's the reliability view in settings. It's a report about your machine since the day you deployed it, and everything that happened every day on that machine. Apparently, on the 27th of March, someone ran Windows Update on this box. But if I open up a production machine or a screenshot from a production machine, it can look like this, where information is blue, warnings are yellow, but this you can see someone apparently installed 3D Studio Max on April 6. And on April 4, the media player crashed, and Windows was not properly shut down, and someone installed a few drivers on the box. You can use PowerShell. We actually had a customer in Munich that wrote PowerShell scripts that went out remote to each and every machine they had and pulled this information out, and they gathered that into a summary report they had in their own help desk environment. They used that to track models that crashed more frequently than others. They could immediately see if they had one or few models in their environment that was crashing more often than others because of this statistic information. They can track applications. They can detect driver issues. They realized that they had a problem with a specific wireless driver because of this. And they can immediately learn what machines that had that, and they can just issue a driver update for those machines. But without this type of information, you don't really know what's going on. And also when you have a user that calls you and say, hey, my machine is not performing anymore, what did you do? Nothing. All right, these 240 apps you installed yesterday from that DVD you got with a magazine you bought, you think they can have something to do with it? Yeah, might. This is good information available in the reliability history. Then we have not necessarily inbox tools, but they are Microsoft now. They used to be separate before, but sysinternals, as you guys probably know, they have a suite of tools, a bunch of them. But two of them are quite useful to use with performance tracking. The first one, Process Explorer, is just the Uber version of the task manager. It's like a task manager on steroids on the machine. But it will give you more details than the task manager would. It will automatically expand the weight chains and all that. So if I have Zoomit, etc. kicking in, it will eventually appear in this view as well. You can see it's green, it's visible. If I start a process, it becomes green eventually. And when I close the process, it removes and, well, turns red for a while and then removes it. Normally, Process Explorer is much trickier. But what you can do in options, let me see where I have it. You can change the speed in which it updates the view that you see. And it could be difficult to see something with only a second or a half a second, but if you add it to 5, you can see processes coming and go more quickly in the process or in the view. I can also use this to have more information about the specific process. You can see I actually have performance information about this process alone in this window. I get the performance graph for this process alone. I get the GPU graph if I have a component that is using the GPU. This one is handy. Used to be a separate tool. But you can use it to find undocumented switches in processes that you didn't know about beforehand. Because it will list all the strings it finds in that binary. And sometimes you can read quite useful information in there as well. Procmon is the fellow companion to Process Explorer. It will help you track what an application does in your system. Yesterday I did a demo on USMT, I think it was around lunch, where I monitored the Notepad process. So I opened up Notepad, I did some changes, and I closed Notepad, and I stopped the trace. But what you can see here is that now Process Monitor has recorded everything that that application does in my system. And while it's useful in USMT to figure out what settings I should migrate, but from a performance point of view, it can learn the paths an application is reading files. You can see there are frequent locations where it tries to find stuff, but doesn't find it. It could be that you have an application that is jumping around to 7 or 8 different locations to find a resource file. By kicking off Process Monitor, you can see those searches and maybe place that resource file together with the first application, together with the application, so it's being read in the first time. You can also use this, you can export this information into Excel spreadsheet to find out the systems, the files that are being used the most on your system. Like the hot files report I showed you before, but you can use that for a specific process, for example, to try to figure out what's going on. Then we have in the ADK, which is the successor to Wipe that you can download. It's a free download as well. Sysinternals are also free. But in ADK, you get additional assessment tools. You have the assessment toolkit, and you also have the Windows Performance Toolkit. And we start off with the assessment toolkit. So let me jump to a server. The Windows Assessment Console, once you have installed it from the ADK, looks like this. This allows you to schedule assessments. And there are some ready-made assessments. For example, there is a battery rundown test that you can do. That will try to run down the battery. It could be that you are evaluating, you're supposed to buy four new laptops, and you would like to verify that the battery life is actually what the vendor tells you it is. So you can run this assessment and figure out for your own and see which laptops actually perform better in terms of battery. I have put a custom job here with just do performance based on file handling. How good is this machine to handle file functions? Copy, move, delete, zip, whatever. It could be a media experience. It could be browsing experience. A bunch of tests that is run over and over again. And of course, you can configure these tests. You can change them. You can configure the settings. Or you can simply just go ahead and run the test. And we'll now kick in and run that file handling test on this machine. While this one is running, because it will take about 90 seconds or so, there is a server side to this. On you go to this machine. This is the ADK setup. When you launch the setup on a server, you can install the assessment services. If you launch the ADK setup, it doesn't look like this. You can install the client, the console. But if you install the assessment services, what you get is a project handler, a server component. It looks like this when it's unconfigured. Where you set up services, you set up images that you can deploy, so you can even do assessment tests on bare metal machines. If you go to a machine like that, it looks... This is a configured server, where I have a single client being added as an image that I can deploy to a bare metal machine. Or I can push out jobs. It's a little bit difficult to see, so let me zoom in on that. This is a job running on the client. So you can have a server pushing out jobs that do assessment tests and then report the result back to your server. So you can manage and view the result on many systems at the same time, server side. Or you can go back to the client and you can do like you did and run the assessment manually. You can also create packages here, so that you can create a ready-made package that you can give to someone to run on the machine, and it will give you a report back of the performance of that system. So we'll let that run, and we'll come back and view the result later on. I have one we can look at previously. This is the report. But it will give you information about how well this system is behaving. And now I got the second result back, so now I have them side by side. And I can see how well they perform against each other. I mean, this is the same machine, of course, but you have to imagine that this was another box. And you get warnings and you get ideas to fix things if there are any issues around from this test. Okay. Then we have the performance toolkit. It's also installed from the ADK. But once you install it, you get a few different components. First, you have the analyzers and recorders in Windows. These are components that will start and stop traces, performance-related traces on your machine. Now, as fine as these graphical UIs are, I actually prefer the command line tools still. So I will show you both of them to you. So there is a Windows performance recorder where you can start and stop recordings related to performance. You can select the detail, you can select what you want to monitor, you can add additional profiles that you load in, and it will start and stop a recording of performance. And once you have a report, you can use the analyzer to view the result. So let me open up a test I have done previously. You need a 30-inch monitor to be able to use this UI. It doesn't play around well when you have just a small monitor like I have right now to see this information. I prefer to use Xperf instead, the command line tools. So, to start a trace on my system, I can open up an elevator command prompt. I can run Xperf, and for example, I can use the profile switch to list the available captures I can do directly out of the box. So by listing profiles, I can see ready-made tests to run. And it looks a bit sort of cluttery, but it's not that difficult. For example, there is a general profile that can be used for generic tests. But there are always two versions of each of those. The one that will store the result in a file on disk, and one that will store in buffer, meaning in memory. If you do long-term analysis, storing in memory is bad. So most tests that are run shortly, they will work great stored in memory. But if I want to, for example, troubleshoot disk issues, storing the result in a disk file on the same disk is not very good. And then you would rather store them in memory. I can list the providers. These are all the components in Windows that you can monitor and select which one you actually want to load. But let me do this. Let me get another command prompt. Do the xperf profiles again. And to make sure I don't make any typos, I will copy and paste the exact name. And then I will run xperf, and I will run start, and I will say I would like to start this. All right. Didn't work too well. What's the fault here? Admin rights. This is the error you get if you're not having admin rights. I don't like the error, but that's what you get. So if I close this again, open up the elevated prompt, and try to type it correctly, and do the exact same command, and maybe I should be in another folder here. It will now start a trace. So now I can do something. I can kick off MS Paint, and I can draw something nice. I have a talent, I feel it. I can launch applications, I can play videos, I can do stuff in Internet Explorer, and whatever application I normally use. I will run the trace for all this time. And when I've done with my work, when I have analyzed or the user has completed their work, I will simply stop the trace, and I will specify a file name to store the output from that trace. So my happy trace.etl. Now, when you stop the trace, it will take some time because it not only stopping the trace, it also gathers all the information on the machine, network info, memory info, into this dump. So yes, indeed, there is a good warning here. It may contain info you will not maybe want other people to see. But again, at least you have a trace. Now I can use xperf to open that trace, my happy trace. I can also use xperf view, but if I just do xperf and the trace, it will actually open up the trace in xperf view. So now I have another view of a trace. And I like this one better, at least on this screen, than the analyzer I showed you before. It can open the same files, but I like this view better. So for example, I can highlight and zoom into selections. I have a bunch of different information has been gathered. For example, disk I/O. And I can use this information to maybe overlay CPU with disk I/O. So I can map processors that are kicking in by what they're actually doing on my disk as well. If I drill down further, you can see process lifetimes from this session, where you can actually see it's all right. I started xperf, check. Then I did some stuff in Paint, check. Then I did some stuff in Internet Explorer. Okay, check. But this allows you to see what's going on in the system. And you can also see all the thread lifetimes that you have. And it will give you black and white information about what's going on these machines. If I go to the, where did my disk go? Up here. If I do a detailed graph on my disk, I will get the sectors on the disk that all my applications were reading and what sectors they were reading on that disk. So if I hover over one of these dots here, you can see that, all right, this one was actually was reading a log file here, or writing a log file. And if you have applications that you have like this, they are almost reading the same sectors all the time, life is good. But this, you can see if you have a spindle disk, if you have applications that are reading and writing all over the place, it's a good indication that that disk might have to be fragmented, or rather defragmented. And you can also get some additional information about the system from here that will give you detailed reports and such that you do not normally have available. But what if you want to have more information? Well, in the left-hand corner here, this is where I can select and clear information I would like to see from that trace. And the more providers you have added into the capture, the more information you will have here to select from. Okay. Another example, we were troubleshooting a machine that had, the mouse was actually stuttering when we moved it around. And we couldn't quite pinpoint why it was stuttering. So after doing a trace of that machine, we start to review it. And we couldn't find much information about what was going on. I mean, it looked quite nice from a CPU point of view. And didn't do much on the disk either. And the disk I/O was okay. Lifetime was good. Did a lot of stuff in Windows, but I mean, it didn't really consume any resources. And a 1% of interrupts, that's pretty okay. But when you have device drivers in your system, they constantly interrupt the CPU with a deferred procedure call. That's the name of it, the DPC call. And what we could find when we enabled that was that we had a constant pegging of interrupt calls to the CPU from something. But by right-clicking here and go to the summary table, we can actually see that a specific driver, where the name has been changed to protect the innocent, was actually reading and causing a lot of interrupts compared with every other driver on that system. Once we figured out what driver it was very easy to update it to a newer version, and the problem went away. But without these types of traces, how would I know that it was this driver? Well, I might have guessed this was a mouse driver, and the mouse was stuttering. All right, check. But it could be more complex than that. All right, another scenario. You have that friend that calls you again and asks you to why his or her machine takes 2 minutes to boot. It took 30 seconds when they bought it. Now it's several minutes every time they boot it. I guess most of you have seen this behavior yourself. A machine that is performant, once you get it, and after a year, it's suddenly slow again. All right. We can use Xperf to do this as well, but we can enable it to monitor the entire shutdown and restart, or hibernate and resume as well. And when we do that, we open up a command prompt. And instead of kicking off xperf, we kick off xboot manager. So I will go into the demo folder and the MMS. And I will use xboot manager, which is also part of the performance toolkit. I will do the trace command, and I will say I would like to monitor a boot. When you hit enter, it will reboot the machine. Start the trace, reboot, and since I'm using a remote desktop connection, yeah, it will disconnect. But I can open up the VM again, and I can see my Windows 8 machine is now rebooting. But during this entire reboot, trace is now enabled. The exact same trace as I did when I was doing my Paint and Internet Explorer work. It will also continue with the trace after you have logged in. So now the machine is up and running again. And if I wait 5 more seconds, the remote desktop service will start. And then I can actually remote into it. And now it will continue to log for 2 minutes. You can specify that on the command line as well. Because Windows lies to you. Just because you could log in, it doesn't mean that Windows is ready to use. Most of you have seen that. You try to start out looking like, takes a while. But this one is now logging to find out all the background processes that are now being kicked in. It could be a roaming profile still being downloaded in the background. It could be a group policy doing something. It could be a service or something on that machine that is kicking in. But I'm happy for now, so I will stop the trace. Yes, please stop. All right, it's in that folder. Check. Come on. It's storing the information into the trace. And once that is complete, here we go. I can go into the folder. Funny. And open that trace. So now I have a complete view of the entire system through the entire reboot and through the login. I can see the IOs, I can see the processes that were kicking in, I can see all the threads, I can see all the drivers being loaded, all of it. All the services kicking in, how long time they take to start, etc. But let me do that, show you a view from a production system. Which is, well, if you compare the size, you'll see that the production system has much more information than a trace from a VM. And you can see it takes longer time to load as well. It's like 5 times the size. So a lot of stuff was going on this machine. When I'll drill down to what was going on, I could see that, for example, it spent some time on, let me open Zoom in here, starting, these critical business services that you need to have. And, for example, at login time, apparently it was busy. Skype update was kicking in, Adobe Flash Player update was kicking in, the group policy was kicking in, the HP service kicked in. But you can see exactly what's going on during this entire reboot and login. You will see how long time group policy took. You will see how long time it took for the login script to run. And this will allow you to very quickly navigate and see exactly what was going on during that time frame. without that information, this information, you are more or less blind with regards to troubleshoot that information. Right. For additional resources around ADK, you can go to this site and find out info about blogs, links, books, videos, trainings, whatever you need to learn more about these components. There are plenty of sessions left at MMS in regards to deployment. I have, I think, 3 more. Yeah, I have 3 more before the week is ended. Please fill in the evaluation, and we will stop the process or the session formally, but I will be around for questions. So thank you, guys, and have a great MMS.